Good morning. This is your stat sensei, Mr. Spensey, and we're going over the normal and inverse norm. Missing an E there, but we're still going to do an inverse. A packing machine is set to fill a cardboard box with a mean of 16.1 ounces of cereal. That's important. Let's make a note of that. So mean is 16.1. Suppose the amounts per box form a normal distribution. All right, that's important. With a standard deviation equal to 0.04. So our standard deviation is 0.04. What percentage of the boxes will end up with at least 1 pound, in other words, 16 ounces of cereal? Well, our drawing looks like this. We have a normal. We have a mean of 16.1. But we're looking for 16 ounces, and 16 ounces is below that, but they want at least. Well, 17 is at least 16 ounces, so we're shading up towards the right. All right, and we're looking for this area. That's what we want to know. So this makes this a norm CDF. All right, so norm CDF, and we have a lower bound of 16. That's the lowest part of my shading. The upper bound, we shaded up all the way to infinity. We have a mean of 16.1, and we also have a standard deviation of 0.04. Lower, upper, mean, standard deviation. All right, so let's go try it out. Second vars, normal CDF, lower bound 16, upper bound infinity 9 to the 99th, mean of 16.1, and a standard deviation of 0.04. And we get 99%, so 0.9937. So most of the boxes are going to have 16 ounces, which is good because they probably advertise it as 16 ounces. 10% of the boxes will contain less than what number of ounces? So this time they give you a percent. If they give me a percent, I know I'm working with inverse norm. So I know that. And we know that this is 16.1 ounces. We know that's the mean. And we see the word what. Anytime we have the word what, we're going to make an X. Well, 10% is less. That means I have to be on the lower side because I need to be less than what? So that means I'm shading from the left. So this is where my percent is. Inverse norm, the first thing the calculator is going to ask you for is for that percent. Then it's going to ask you for the mean, which is 16.1. Then it's going to ask you for the standard deviation, which in this case is 0.04. So this is my percent, this is my mean, this is my standard deviation. So second vars, normal or inverse norm. My area, 0.1. My mean, 16.1. And my standard deviation is 0.04. And we shaded on the left-hand side, and the calculator reminds us to write that down. Make sure we highlight left. And we end up getting 16.04873. 16.0478. And that will work. 80% of the boxes will contain more than what number? All right, so they gave me this. So this tells me I'm working with an inverse norm. They gave me a percent, so this is going to be an inverse norm. And we know our mean is 16.1, so that's not changing. And it says more than what? So here's that thing, that what? Well, 80%. 80 says more, so that means I'm going to be above. That means I'm shading from here this way, and 80% is more than halfway, so I'm going to be shaded more than half. So this is 0.80, and we're looking for what that value is right there. We're looking for this value right here. So inverse norm, my area is 0.80. My mean is still 16.1. My standard deviation is still the 0.04 that we've been working with. So probability, mean, standard deviation. But this time we start at the top. And so if we're starting at the top, that means we're on the right-hand side. So we're shading from the right. So second vars, inverse norm, 0.8, mean is 16.01, or 16.1. Our standard deviation is 0.04, and we're shading from the right. So 16.0663. All right, the middle 90% of the boxes will be between what two values? All right, so here we go. Our mean is 16.1. And so I'm looking for two values. I'm looking for this, which is my lower, and I'm looking for this. So we're looking for a lower and an upper, and our area happens to be 0.90. Once again, they gave me a percent, so that makes this an inverse norm. So inverse norm, our area is 0.90. Our mean is 16.1, and our standard deviation is 0.04. That still hasn't changed. So percentage, mean, standard deviation, and we happen to be in the center, all right, or middle. So let's go to the calculator. Second vars, inverse norm, 0.9, mean, 16.1, standard deviation, 0.04. Oh, they asked for the center. There it is. And we got two values. So we ended up with 16.0342 and 16.157. Oh, 1657. 1657. Where this is my lower bound and this is my upper bound. I'm going to rewrite that, 16.1657. There we go. So that's my lower, that's my upper. E, what is the probability that a group of 9 randomly selected boxes weighs less than 16 ounces? All right, so they're asking to find the probability, so that means I'm not working with an inverse norm. They didn't give me the percent. Well, we know the mean is 16.1, and we want it to be less than 16 ounces. All right. Well, the fact that I have 9 tells me I'm working with a z-test because I'm not working with just one. So I'm working with a z-test. The mean is going to be 16.1. The standard deviation in this case is still the 0.04 that we've been working with. It's going to ask you for the X bar, which is 16, and it's going to ask you for the it's going to ask you for your sample size, which is 9, and then it's going to ask for the direction of your shading. So we're going to clear that out, press stat, arrow over to stat z-test. So stat, arrow to test, z-test is the first one. Make sure stats is highlighted. Our mean is 16.1. Our standard deviation is 0.04. Our X bar is 16. My sample size is 9. Less than is highlighted. Calculate. Oh, I meant to change this. Instead of a less than 16 ounces, less than 16.06. Less than 16.06. So norm CDF, I'm going to change that to 16.06. Otherwise, I get a 0 probability, which is not as much fun. So here we go. Stat, test, z-test. Change our X bar to 16.06. Everything else remains the same. And we get a super, super small probability. I mistyped the number. I just checked it and it came up with the wrong number. Yeah, I typed in 16.05. It should have been 16.06. There we go. We still get a super small number, but that's what I was looking for. 0.0013. 0.0013. So not very likely that it's going to be less than 16.06 for an app for a group of 9. All right. Finally, what's the probability that a randomly selected box of cereal weighs less than 16.06? All right, so this is the randomly selected box, and I changed it here, but not above. So this is 16.1. This needs to be 16.06. And we're working with a box. So that just means that's one box. That's going to be a normal CDF. The lower bound is negative infinity. The upper bound is 16.06. The mean is 16.1. And the standard deviation in this case is 0.04. Lower, upper, mean, standard deviation. Second vars, normal CDF. Lower, negative infinity. Upper, 16.06. Mean, 16.1. Standard deviation, 0.04. And we end up getting about 16%, so 0.1586. Now, the interesting thing is if you notice, we had the same 16.06 here and the same 16.06 there, but they differ, the answers differed very substantially. It's much less likely to have a group of 9 having the average, it's only 0.0013, versus having a single box. There's a 16% chance a single box. All righty. Appreciate you watching, and we will see you on the next one.